Okay, this is part 3 of developing this board, and this is basically an ANS simulator, but unlike my previous version, this one's going to be automatic. These 4 buttons here are going to set the output voltage of the 4 different conditions. At the end of the last video, I said I would be adding a 12 volt regulator so I could take the supply directly from the rack at 24 volts. So that would be 24 volts coming in here eventually when I turn it on. And this little device here is a 12 volt regulator, and there's a couple of capacitors associated with that. The only other thing I've done is I got rid of my resistor board there and replaced that with some normal resistors. I didn't have a 2K, so I've put 2 1Ks in series there. And I put a 220 ohm output resistor, so that's sort of in line with the output going to the ANS input, and that's just kind of just to reduce the potential of current going into the Vipedia or the B&B. I may well put a current limiter circuit on there with just another transistor, but at the moment that's what I've got. All right, so let's just double check that all of the voltages that we're getting from the 4 buttons still correspond. So I'm just going to fire up my power supply. You'll hear the fan in the background probably. It's just booting up. There we go. And we're on. So 24 volts coming in here, as I said, regulated down to 12. It's defaulted in position 1, which is our high voltage fault. And you can see we're getting 5.28 volts, and I'm sniffing off the voltage here at our output. Okay. And then if I press this button, which is our high ambient simulation, so we've got 0.8 volts, that's what we had before, so that's good. And then the low ambient condition, 4.3 volts, and then our low voltage fault, which is roughly 0 volts. So that's all good, all still working. Next thing then is to get a Vipedia plugged in, and we will do some real testing, okay? Right, so it's all wired up. This underneath this is a Vipedia. I'll show you in a minute. There's the breadboard with our ANS simulator on it. This BOA is wired into contacts in 1 to 4 and, sorry, not 1 to 4, 5 to 8, and input 5 is configured as an ANS. That's just a switch box to activate some other contacts, and I've got switch 1, a trigger for pink noise. I'm using my audio listening box, which is over there, and it transmits as Bluetooth, and that's the Bluetooth speaker, and just another wireless mic so you can hear the output. Okay, so at the moment we've got this one selected, and if I just get my voltmeter here, it's all wired into the ANS now, and measure at the BOA, we're getting 4.3, so that's a low ambient noise condition. If I press the blue button, we are now getting out 0.8, so that's a high ambient noise condition. Okay, so if I broadcast the pink noise now with it in high ambient noise, let's just set the voltage trigger on, and you just have a listen. Okay, stop that. Now we put it to low ambient noise, let it settle for a second, and trigger again. There you go, much quieter. So brilliant, that is working. I'm sure you heard the attenuation in the audio, but what I'll do now is just going to rig up another camera and show you on the laptop using the dynamic tool just the impact that it's having. Okay, so you see the laptop. Sorry, I've just rigged the camera up rather than screen share, so it's not great. Let's just angle that down a bit. There we go. So I've got the dynamic tool here running. The ANS is currently set to simulate a high ambient noise condition. So let's just start the pink noise. So I'll use my cursor pointer, so there it's on this channel. It's setting at about -2 up here again. Now we do a low ambient noise condition and start again. And you see it's dropped down -10, -12, so that's 10 dB reduction in gain. Okay, just to now check the fault condition simulation. So currently I've got 17 faults. There's loads of faults on this Vipedia because it's a config from Gatwick. But if we just now press our low voltage fault, okay, so that's now at low voltage, so close to 0 volts, and we'll just wait for another fault to drop in. There we go, another fault's dropped in. If we go back and see what that is, go to active, and that's my ANS input, which I'm using analog input 5. Okay, so it's gone into fault. Right, I've done a fault clear and we're back to our original 17 faults there, you can see. Now I'm going to press the high voltage fault condition. We wait for that to drop in. So I'm just reading on the meter, it is reading 5.2 volts going in, so it's more than the 4.8 fault condition. Right, well, I've left this for several minutes now and it hasn't gone into fault, so I don't quite know why that is. If I check with my meter here, yeah, let's put it under this camera so you can see. And if I go on to the input going into the ANS input, you can see clearly it's at 5.2 volts. And the manufacturer's documentation clearly says if it's over 4.8, it's a fault condition. And I've had it on 5.2 now for good 10 minutes and it's not got into fault. So I'm going to do some more experimenting with that, but for now I think this is good enough. I will probably have to adjust this Zener diode for the fault condition, I suspect, but it's virtually there. The high and low ambient noise works, the low voltage fault works, you can see that it attenuates the output, so all good. Right, just looking at the manufacturer's instruction sheet here. Admittedly, this is wired into a B&B rather than going direct into a Vipedia as I was, and maybe that could well be the reason that there is a difference. But you can clearly see here it says anything over 4.8 volts, and I was at 5.2, is a fault condition, and we didn't get a fault. We definitely got a fault when we went down to below 0.3. And we did get the audio attenuation when we was between 1 to 4. Anyway, I'll look at that separate. I do suspect it's because it's wired direct to a Vipedia and there must be some difference in the monitoring arrangement or whatever. Maybe I'll try it through a B&B another day. But I'm definitely providing 5.2 volts, so that should have gone into fault in my view. Anyway, the schematic I've put together here, I'll try and share that somewhere. So if you look here, here's my voltage, here is the voltage regulator, so that's bringing the 24 volts down to 12 volt supply, just a basic LM7812. There's a whole LM78 range for all kinds of voltages, and it's probably the simplest voltage regulator circuit you can really choose, which is what I wanted. And here's my voltage reference circuitry here. So there's my 0 volt, which is just tied to ground, my 4.3, which uses this Zener diode and this resistor pack, the 0.85 volt, which uses a Zener diode and then a voltage divider using these two resistors, and this 5.1 or 5.2 I was getting, which again is the resistor pack and the a 5-volt Zener there. And then the various stages it goes through, you've got the button selection here, selecting which condition you want to simulate, a high voltage fault, high ambient condition, low ambient condition, or a low voltage fault. That goes into the data feeds on this encoder chip, the CD4532. From that we get an encoded output, so it's like a binary 0001, 10 or 11. That goes into our latch circuit, which was a dual D-type flip-flop or a CD4013 chip. That latches basically this A1, A0 and A1 on these two legs. That then goes into our multiplexer to choose which channel we are routing to our X and Y common outputs. Okay, all the X channels are wired to LEDs to tell us which mode we've selected, and they've got a current limiting resistor pack as well. And all the Y channels, well, they're wired to my voltage references, 0, 4.3, 0.85 and 5.1. So they come from down here basically, they connect through. And then that goes to my output stage through this op amp, and the op amp is driving this output transistor, which is regulated through this feedback to control that transistor to match the voltage that we present here. Okay. I've got a 10k to ground in case nothing's connected to this transistor. You've got something to pull it to ground, and as I said earlier, I've put a 220 ohm resistor in line with the output just to kind of protect the output currents somewhat going off to the ANS input or your BMB GPIO input. And that's it for now. I think I might decide to get a PCB made for this, and I will share that. You can order it yourselves and build one up, but I'll probably do that, and I'll do another video follow-up. Okay, catch you later.